What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are continuing with the SAT subject test of Math Level 2. I've gotten so many people asking me about this and to do so many requests to do this. So I did one last week and I think it went pretty well. I think people liked it. So I'm going to do the same thing again, just getting this all set up here. And let's see. We've got this test that lasts 60 minutes. I'm just going to make sure I did the same thing here. Hold on. The last time I did it, I set a clock for 60 minutes. Yeah, 60 minutes. Okay, so it's a full hour. Yep, that's what we did last time. Just can't remember. So I'm way less familiar with this test, obviously, as you can tell, than I am with the actual SAT that I've done. I know like the back of my hand. But anyways, so we're going to jump into it right now. So I got the timer set up. And again, I'm doing it in real time for the first time. So I've never seen it before. I may have seen some of these questions when I tutored some of my students, but it might be like a handful of them. So it's meant to be an authentic test-taking experience. And then we're going to grade it at the end, see how we do. And I will explain the problems as I go through them, but it's going to be, again, under time conditions. So I'll be going fast just to mimic what you guys actually go through. So I'm not going to do like a 5-minute explanation for a question that it's not realistic to spend 5 minutes on the real test, right? So it's going to be really applicable, and that's the whole idea. So I got practice test 2 queued up here, and again, because I'm doing it in real time, I won't be able to see your questions or answer your questions until the end of the live stream. So put your questions up here, but I'll go through them at the end. Without further ado, we're going to start in 3, 2. By the way, there's 50 questions. 3, 2, 1. Let's do it. Okay, if 2 to the 1/5 equals this, then a cubed equals... Okay, so that just means we'd cube both sides. Cube it and multiply it, so it's 2 to the 3/5 power. Oh, it's some decimal, so it doesn't even matter. But really, this is the same as... 2 cubed, if you want to do it like this, to the 5th power. I don't even know if maybe I'd recommend doing this, maybe not, because... So you know what I'll do instead? I'll do this. 2 to the, let's keep it real simple so I don't make any mistakes. 2 to the 1/5 power is this. And then we're going to cube it because that's what they're saying to do. And it's 1.515. 1.516. C. Okay, next. Oh, that's it. Numero dos. If in the xy plane, the graph of which of the following has a positive y-intercept? La-da-da. Right here, positive 1. This is negative, negative, negative. No y-intercept. Next is the net for a rectangular solid shown in the solid form. What is this volume? All right. So you can kind of think of like folding it up. These are the sides, and then this would be the top of the box. So the dimensions are 8 by 2 by 6, right? If I were to fold it up into a box like this, the top, the height is 2. This long part is 8, and this part is 6. So 2 times 8 times 6, 16 times 6 is 96. That's it. If p is a prime number, then 2p plus 1 is a prime number. Which of the following prime numbers could be a value p that yields a counter example to show that this is not true, okay? So 2 times p is, in this case, would be 38 plus 1 is 39, which is not prime. Hey, it works. This doesn't work because that's 23. This would give you 11. 2 times that is plus 1 is 11. This would give you 7. This would give you 5, which are all prime. So we're trying to find the one that's not a prime. If the parabola in the figure above is translated 3 units to the right, 1, 2, 3, like this, which of the following could represent the equation of the translated parabola? Okay, so the current parabola might be like x squared plus 2. The translated parabola, when we go to the right, we're putting a 3 in like this. Positive would be going to the left, plus 2. So x minus 3 plus 2, and it's this one. Yes, I'm feeling good about that. All right. Next, in the xy plane, the graph of the linear function f has a slope of 3. Negative 3, the graph of f passes through 2, 6. Which of the following could be an expression for... Okay, got it. F of x, let's do point slope, maybe. So it's y minus 6 equals negative 3 times x minus 2. Distribute. Negative 3x plus 6 equals y minus 6. Add 6 to both sides. And that's f of x is the same thing. We'll say f of x equals negative 3x plus 12, which is this guy. Let's make a better circle. Okay, whatever. Now let's go on to numero number 7. What is the range of the function whose graph is shown above? The range. Oh, it's everything less than 2, right? You see the arrows going this way and this way into negative infinity. Less than or equal to 2. Yeah, that's it. All right, done. That was pretty quick. 8. The table above gives the number of cellular phone subscribers in the United States from 1995 to 2005. Which of the following scatter plots best represents the data above? So it looks like it's going 40, 40. It's getting bigger every time. This makes no sense. Why would it be going down? It should be going up. This makes no sense. Same deal. What? And then why are they showing a dip? It didn't drop. It's always consistently going up. So this would almost be right, except it's got to be E. That's pretty much it. Little data analysis, graphing. Okay, this equals this. What are the zeros? Okay, this is a difference of squares, so let's factor it. It's x minus 1 times x plus 1, aka the zeros are positive 1 and negative 1. Da-da. All right, next. So we're doing good right now. Like, we're on the 10th problem and only burned 5 minutes. A bag contains 5 black balls and 20 white balls. If a person draws 4 white balls out of the bag without replacing, what is the probability that the next ball drawn at random will be black? Okay, so we've drawn 4 white out, so now we've got 16 left. And so now we've got a probability of 5 out of a total of 5 plus 16, which is 21. Done. Wait, what? It cannot be determined. Hold on. Did I miss something? No. It's definitely determinable. Okay, sine of x equals this. Then cosine of, oh no, half-angle theorem. Blah. Shoot. Did we have to memorize the half-angle theorem? Because I don't remember it. Let's see if I can figure it out. Okay. Oh, I can figure this out. Okay, so sine of x equals 0.90. So let's take the arc sine of both sides. If you knew the half angle, it's probably easy, but let's take arc sine. Let's keep it in degrees. Inverse sine of, what is it? 0.90. Okay, so x equals 64.158. So then let's take half of that and take the cosine of it. Divide by 2. And then cosine of that equals 0.847, which rounds up to 0.85. All right. So I do a little creative problem solving on my feet. Next, what are the values of y that satisfy the inequality? This guy. Okay. 0 obviously works, right? Because 0 times 0, we'd have 0. Wait, is there an easier way to do this? Oh, this is no, what am I talking about? 0 doesn't work. It's less than. I thought it was an equation. This is impossible. This is no real numbers. Because this is just like the negatives cancel out, right? So this is basically, these are going to always be equivalent. Absolute value y is the same as absolute value of negative y. It's just positive y. And then it's negative y times y is less than negative y times y. Never. It's never going to be true. They're always going to be equal. It's the same. In the xy plane, a parabola is symmetric about the line x equals 2. Here it's x equals 2 and passes through the points 4, 2. Which of the following points must also be on the parabola? Wait a minute. Oh, it's... I bet you this is going to be there. This is 2 away. So this would be 2 away. This would be 0, 2. 0, 2. Guarantee it. Okay, why do I know that? Because this is symmetric about this. So if we have something at the coordinate 2 here, that's 2 away from the line of symmetry. 2 away this way. It's got to be 0, 2. That's funny. Because I was actually at first like, how do you do this? But then that just popped into my mind. I bet you it's the symmetric point. All right, the function p given by this can be used to model the population of a town at time t years after the last census. How many years from the last census will it take for the town's population to double? Wait. Oh, I think what we're doing here, so it's right now, this is the current level. So we want to know when is it going to reach 6246 equals 3123 e 0.143 t, and then we solve for t. Divide by 3123. Divide by 3123. This of course is 2 equals e to the 0.143 t, and then to solve that we take ln of both sides, and then this kind of just becomes 0.143 t equals whatever ln of 2 is. 0.6931, and then divide by 0.143. Oops. 4.85 right there. Feel pretty good about that. Okay, next is this one. Deviation of observation xi is calculated by the formula x minus xi. The standard deviation, sort of, where x is the arithmetic mean of all the observations. Yeah, this is, so what is the deviation of 15 in the set of observations of, okay, so we just have to take the arithmetic mean of these. So 10 plus 12 plus that is 36. 36 plus 33 is 69. Divided by 5. 13.8, and then it's 15 minus 13.8, which is 1.2, right? Yep. Positive. Yeah, because it's that minus the mean. All right, next, if y equals this, what is the value of y when it is twice the value of x? Okay, we'll just substitute in 2x for y. Simple. And then subtract 4x from both sides. Negative 2x equals negative 12. X equals positive 6. Divide by negative 2, right? And then we can double check that. If I plug in 6 is 24 minus 12 is 12. So what is the value of y when it's twice? It's 12. That's when x equals 6. If g of x equals this, okay, a little function notation. What is g of x equals this, and f of g of x? It's this. Here's why. If f of g of x is this, that means I'm plugging this in for the x, which would make f of g of x exactly what it's saying up there. So therefore, f has to be just this guy. Okay, next, score, frequency. What is the mean of the scores in the frequency distribution shown above? Okay, all we do here is we multiply this times this, and then add them up and then take the mean, okay? So there's 3 10s, which is 30, 4 15s, which is 60, 7 20s, which is 140, 2 25s, which is 50, 8 30s, which is 240. Oops. Oh, wow, I just wrote 340 instead of 240, but I caught it. 0, 9, 13, plus 9 is 22, carry the 2, 3, 4, 5, 5, 20, divided by 24. Because that's how many total there are, 21.66666. There we go. Point P has coordinates x, y, where x equals cosine of that, y equals sine of that. Oh, I got it. The point P is on the graphs of which of the following? What? Okay. Oh, I get it. cosine. I think it's this. All right, here's what I think is happening. This is really confusing, but I think they're referencing the fact that sine squared plus cosine squared equals 1. It's almost irrelevant what this is. I could plug all these in and check it. I don't think I'm going to do that. I think it's not this, because those two are not equal. This makes absolutely no sense, because this will be definitely less than 1. There's no way, because if one, it's just, this is impossible. So it's 2. I'm just going to roll with it, and we'll see if it's wrong. If it's wrong, I can show you how to verify it. But I'm pretty sure it's just referencing that identity that sine squared plus cosine squared equals 1. Okay, next, T1 equals 1, this. Okay, in the recursive defined above, T1 is the first term of the sequence. What is the sum of the first 4 terms of the sequence? Okay, so we've got 4 is the first term. Okay, we get the second term by plugging the first term in here. So it's 2 times 4. Second term is 8. Third term is 2 times this, 16. Fourth term is 32. So 12 plus 16 is 28, plus 32 is 60. It's not there. For n is greater than or equal to 2. Yeah. Second. It's 8. 28. It's doubling each time. Oh, plus 1. I didn't see that. Sorry. 8 plus 1 is 9. 18 plus 1 is 19, and then 38 plus 1 is 39. So 4 plus 9 is 13, plus 9 is 32, plus that is 71. Which of the following expressions approaches 2 for large values of n? Not this one. This would become just 1. This one would become 1. This one would become 1. Because I'm just thinking that like this would be like 1,000,000 over 1,000,002. It's basically 1. This would be like 999 blah, blah, blah over 999,999 over 1,000,000. That's about 1. This is about 1. You see how these are, we just care about these terms. The numbers almost go away. This one. This one's out. I don't know what that would approach. Not it would diverge. But this, because this would be like, if we plugged in 1,000,000, it'd be like 2,000,001 over 1,000,000, which is about 2. That is it. What is the value of f of g of pi 4, where f is this and g is sine of x? Okay, so we're plugging in pi fourths for sine, and that's, I know that's like 90, and I can plug in the calculator, but I remember sine of 90 is 1, so then we're plugging in 1 for this function, right? G of 4 is just 1, so we plug it in there, and then it's 1 over the square root of, wait a minute, 1 minus 1 squared. That's 1 over square root of 0. That's undefined. No. Sine of pi fourths may not be 1. I must have misremembered that. Okay, I messed up. Let's go back to radians. Sine of pi fourths. Is that 1? Oh, what am I talking about? Oh, sine of pi is 1. My bad. Okay, then when I plug that in for here, so then it's that value, whatever that is, divided by 1 minus that value squared. So let's do it carefully. So here, let's see if I can get this good. 0.707106 over square root of 1 minus this squared. Just, oh, it's 0.5. How nice. 0.5. So then it's 0.707106 over the square root of 0.5. So then it's, here, let's see if I can do this. Square root of second answer equals that. Oh, it's the same thing. So it's just 1. It's this over itself, which is just 1. That's pretty cool. A pair of sneakers at a store originally sold for $N. After 1 month, the original price was reduced by 20%, so it became 8.8 N. After another month, the discounted price was reduced by 25%, so it became 0.75 N. What was the price of the sneakers, including a 5? Then we're adding 5% tax. Then we multiply this by 1.05 because now we're adding on 5%. So this is taking away 20%. That's why it's only 0.8. Then this, then this. Now let's multiply it. 0.8 times 0.75. 0.8 times 0.75 times 0.05 equals 0.63. Numero next. In the xy plane, the line through 1, 3, and 3 is perpendicular to this and that. Got it. So we need to do slope calculations. 1, 3, 3, negative 1. So the slope of this line, subtract down 3 minus negative 1 over 1 minus 3, which is 4 over negative 2, which is a slope of negative 2. So then this one has to be a slope of positive 1/2, negative reciprocal. So let's stack the coordinates again, like I always say, negative 1 over y. Subtract down 2 minus y over 5 minus negative 1 has to equal, like I said, positive 1/2, perpendicular. It's a plus. So then it's 2 minus y over 6 equals 1/2. Cross multiply. 6 equals 2 times that is 4 minus 2y minus 4 minus 4. 2 equals negative 2y. Y equals negative 1. Dunzos. We is at the halfway point. For 5 values for the function f are given in the table above. If f is a polynomial function, which of the following conclusions can be inferred from the given values? All right. Graph of f has at least one intercept. Wait, what? Oh. Okay. Okay, so it has a y-intercept here. I don't see an x-intercept. Oh, I know what it's doing. I get it. It has to have at least one y-intercept here because it's going from positive to negative, but that's all we know. So it's like going down, and it's going back up, and then it's going like down. Something like that, 2 and then 2.5, something along those lines. Let's see what we can. The graph of has at least one x-intercept. Yeah? I would just go with this, to be honest, because that's what we just figured out. It has to have an x-intercept. F has an inverse function. I mean, I don't even know. The graph of f is not symmetric. I mean, we don't know that because we don't know what 2.5 is. It's A for sure. Because if they said 2.5 was also negative 13.5, it'd be symmetric. It's increasing. I don't know. 0 to 2. I don't even know why I'm looking at these. 0 to 2. We can't say. It looks like it, but it could also dip down in there. We have no idea. We have no idea what the degree is. That's just ridiculous. Okay. Sort of a waste of time, but I just want to go through them just to be sure. 2 over 1 minus x equals k, which is the following equals k over 4. All right, check out how we do this. 1 minus x equals, I'm going to say k over 1. Let's multiply both sides by 1/4. And we get k over 4 equals 2 over... Oh, watch this. This is actually pretty cool. And then we can just simplify this to be 1 and that to be 2. So it's 1 over 2 times 1 minus x, which is the same as 1 over 2 minus 2x. Okay. Halfway point. Bit of a waste of time. I should just zoom out, but whatever. Oh boy. No. 27. If 1 0 of a function with period 8 occurs at x equals negative 1, a function with period 8 occurs at x equals negative 1. Let's draw this out. I assume they're talking about a trig thing. So here's x equals negative 1. And in a period of 8, so it's going to go like this. And then here it would be 7. So, and then there's also going to be a 0 right in between, right? That's a period of 8. I'm assuming this is a trig function. I have no idea if that's a false assumption. Another 0 must occur at 3. I don't see that as an option. 7. 4 would be 11. I don't see that. 15. I see that. Hold on. Let me just make sure. 18 wouldn't work. 19 and 20. Yeah, none of these other ones would work. According to my little graph, if it's accurate, I think that's right, though. I think that's how you do it. If f is defined for all numbers x by this, for which of the following values does f of x equal f of, okay, so the way we're going to set this up is when does 1 minus x squared equals 1 minus x squared over 3, and then solve for x, multiply both sides by 3, and we get 3 minus 1 minus x squared. I'm going to add 3x squared to both sides. And then I'm going to subtract 1 from both sides. So it's 2 equals 2x squared divided by 2 divided by 2. 1, x equals plus or minus 1, which is 1. And then we can plug it in, right? Like 1 minus, oh yeah, it's 0. It's so simple. I didn't even need to do that. That's funny. You know it has to be 0. Yeah, whatever. Okay, let a, b, x, and y represent real numbers greater than 1. Okay. If y equals b to the ax, which of the following must be true? Oh, they're converting it to logarithmic. So, hold on. Log, I have to remember this. Log a of b equals c is the same as a to the c equals b. So if it's, let me rewrite it like that. B to the ax equals y. Then it's, I don't know. Sorry, just have to remember it this way for some reason. So then this is the same as log base b of y. Wait, hold on. Yeah. Of y equals the exponent on the other side. See how the exponent goes there is ax. So log base b, the only one where I see log base b of y is here and here. So immediately I'm going to cross these off. I'm pretty sure those are gone. And I think it's this. Yeah, log base b of y equals ax. Pretty good, I must say. Pretty good. Okay, next. For all the x and y such that this does not equal 0, this. Then f of this equals what? Okay, let's plug in so we're plugging in negative x for y. So x times negative x over x squared plus negative x squared equals x times negative x is negative x squared over, that's x squared, and becomes a positive x squared. So then it's negative x squared over 2x squared. These cancel out, and it's negative 1/2. The lengths of the sides of an isosceles triangle are 5, 10, and 10. 5, 10, and 10. What is the measure of the angle formed two congruent sides? This is our x. Hold on. You gotta remember how to do the... I think I can just do this here. Okay, I'll draw an altitude. Yeah, I think I can draw an altitude. And that altitude, let's call it y. And forms a 90-degree angle. And then this side here is 2.5. And then I can use... Okay, got it. Then I can find this angle, which is half of x, which we'll find that. So I can find that by, I can set up a little trig identity. So I can say sine of, let's call that z. Sine, ooh, that blue is terrible. So we'll do sine of z equals opposite 2.5 over hypotenuse, which is 10. And that's 1/4. So then we take arc sine of 1/4 to find angle z. It's in degrees, right? Okay. Arc sine of 0.25. 14.47, and then that's half the angle that we're trying to find, so we double it, and we get 28.95. 28.95 or 29. I feel pretty confident about that. That makes sense too, because this is going to be smaller than 60. It has to be, because these are going to be the bigger angles. I think that makes sense. The 355 students in school are to be seated on chairs in the gymnasium. The chairs are set up in rows so that each row contains the same number of chairs. Each row is fully occupied except the last row, which has 5 empty chairs. Wait a minute. Okay, I think I got it. I'm going to try and set up an equation. Wait a minute. This is bad. No, what am I doing? I should just be dividing. I should be dividing these numbers by these. And whatever I get is the remainder. And I subtract the remainder from this number. If it equals 5, then I cross it off, because which cannot. I already know that this is going to have a remainder of 5. 10 minus 5 is 5. So that last row would be like 5 short. 15, let's do 3. Okay, that's how you do it. So 355 divided by 15 is 23. Hold on. 23, I wish it would give me the remainder. 23 times 15 is 345. With a remainder of 10, and they would go in the last row, and there'd be 5 empty, so that's out. 355 divided by 20. So 17. 17 times 20 is 340, and we'd have a remainder of 15. That, again, we'd have 20 minus 15, we'd have 5 empty. 355 divided by 24. Bet you it's this one. 14, yeah, definitely this one. Has to be times 3, so we get 336, and then 336, and then we've got 19 no, that one works. 19 students left to seat, 24 in the row, so we'd have 5 remaining. It's got to be 25. So let's just confirm. 355 is 14. Is 350, and then there's 5 left over that need to be seated. They would be seated in the last row of 25, which would mean there's 20 empty chairs. So 25 does not work. Don't know a better way to do it than that. I couldn't think anyways of a better way, but I know that's right. The rate R of decomposition in moles liters per second of a certain chemical is given by the formula this, where C is the chemical's concentration in moles per liter, and K and M are constants. If R equals 0.1 and C equals 0.2 and R equals 16, C equals 0.8, what is the value of M? Okay, just plug and chug. R equals 1 when K equals... Oh, we have to, I get it. We have to solve for K. So R equals 1 and C equals 0.2 to the M. So when R equals 1, and then R equals 16 when C equals 0.8. Okay, we got a system of equations here. What is the value of M? Hold on. I think K equals 5. Wait, does K equal 5? Ah, it's impossible. No, what am I talking about? Okay, I don't think, no. Okay, I think this is what we have to do. I'm a little baffled at this one. I think I can multiply both sides by 16. Okay, then I know that 16 equals this. Then I can set these two equal to each other. Then I can say, because then I can substitute, if this equals 16, then I can take this and plug it in here. So I have 16K times 0.2 to the M equals K times 0.8 to the M Divide both sides by k. Then I have 16 times 0.2 m. I can't do this as 0.2 to the third. Yeah, that doesn't work. Okay, and then I guess I'll take the log of both sides or something. This just seems weird though. So then I take log of 16 times 0.2 m equals 0.8 m. And then since these two are multiplying, the rule is you got to break it up by addition. So it's log of 16 plus log of 0.2 m equals log of 0.8 to the m. Okay, log of 16, and then I subtract this from both sides. So then I have log of 16 equals log of 0.8 m minus log of 0.2 m. Then I can use another rule to make that division. Log of 16 equals log of 0.8 m over log of 0.2 m. And then I can use another rule where I can bring the m down out in front. So it becomes, actually, let's do it here. So it becomes m, the m's come down. And then it's m in front, this is gone. And then it's log of 0.8 over log of 0.2. Okay, so hold on. And then, so what's log of okay, I think I did this right. Log of 0.8 equals divided by log of 0.2 equals 0.13864. And then we have to divide that by this. 0.13864. Right? Then I'm isolating m, dividing both sides by that big constant, and I get m. So I have to do log of 16 divided by that. Log of 16 divided by answer. Darn it, 8.684. That is not right. No. Okay, hold on. I burned a lot of time on this question. I got it wrong for sure. Hold on, let's see if I can figure it out. I just don't want all this writing here because it's taking up my eye. Here, let's just erase it. Darn it, that seemed like it was right the way I was doing it, but it's wrong. I shouldn't waste too much time. You know, maybe I should come back to this because I burned a lot of time. 33. So my mind, my subconscious will probably work on it while I go on, and then I'll see if I can figure it out. Okay, 34. The figure above shows a portion of the graph of a function where f of x equals sine of 2 sine 2x. One of the vertices of triangle ABC is a maximum point of f, and the other two vertices are consecutive x-intercepts. What is the area of ABC? Ooh, interesting question. Okay, so first of all, this is doubled. So the 2 in front makes this a, whatever it is, it's 2. So so this is the height, is 2 up. And then we just need to multiply that times the base and take 1/2 of that. So then the question is, so normally it would go up at 0 and it would come down at, oh, this is actually too easy. We're allowed to use a graphing calculator. Doesn't even matter. So I don't need to kill myself figuring that out. But this shifts the period. So when there's a 2 there, the period is actually half. So instead of going from 0 to, so usually it's 2 pi, right? And this would be pi. This would be pi halves. So it's now pi halves times 2. And then, but we have to take 1/2 of that. Those cancel out. So it's pi over 2 is the area. But I'm going to double check anyways. Y equals 2 sine 2x. Right? And there it is. Pi halves. Boom, boom. I was right. And then it goes up to 2. Yeah, I forgot on this test you can use that to your advantage. A piece of paper is 0.03 inches thick. Each time the paper is folded in half, the thickness is doubled. Someone claims that the paper can be folded in half 12 times. So 0.03 times 2 to the x power. Like, it's doubled every time. So if this were true, how thick to the nearest foot would the folded paper be? So 0.03 times 2 to the 12th is what it would be. 122.88. 123. Yeah. All right. Next is this one. In 3 space, point A has coordinate 15, 1, 5, negative 1. Point B is, what is the distance? Oh, God. Distance formula. Hardcore. There's a formula for this, and I think I know it. I think it's like this. I think it's just the distance formula, like one notch up, where it's literally, hold on, am I oversimplifying it? I think it's x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared, and the square root of that. I think. Let me see if that makes sense. Hold on. Oh, shoot. I think I undid my last circle. Yep, I did. I knew it. Hit undo too many times. All right, let me think about this. So we go 1, 1, 5, 1. So then we're going to negative 2. So negative 2 is 3 away from here. Positive 3 is 2 down. And then 5 is like 5 back. Right? Like, I know how to do this. It's if in a 3D cube. I've done that before. It's like you have to, like, if we're trying to find from here to here, first we'd find like this distance across here, then we'd find this distance, and then we do Pythagorean's theorem like that. I probably could do that. Actually, wait a minute. That works. So if I find the distance between the x and the y, go that way, and then do a new try. So let's see if this works. So then we do 1 minus 2 is 3 squared. 5 minus 2 is 2 squared. Square root of that is 9 plus 4 is 13. Square root of 13. And then we do the square root of 13 squared plus 5 minus 1 is 6 squared is 13 plus 36 is 49, and square root of 49 is 7. I think that worked. I think that's right. Let's see. We'll check later. There's probably a formula. I just don't remember it. Which of the following is equivalent to cosine theta minus this, minus the inverse? It's the same as, this is secant. And let's see if we can get any clearer on that. Let's see. How can I figure this out? Cosine of theta minus secant of theta. Okay, here, let's do it like this. That's the same as cosine squared theta over cosine theta minus 1 over cosine theta. And then we can combine these, and it's cosine squared minus 1 over cosine theta. And cosine squared minus 1 is the same as sine squared. That's because sine squared plus cosine squared equals 1. So, oh, sorry. It's negative sine squared over cosine theta. And then we can break that out as negative sine theta over cosine theta times 1 over cosine theta, which is negative tangent over cosine theta, which is That's sine. Oh, wait, hold on. Can I reduce this more? Tangent. Wait, I know I'm going to get the sine over cosine over cosine over 1. Multiply. And then I get negative. Oh, I come back. Oh, I'm tempted to say it's this, but I think it's wrong. All right, I think I did something wrong. Hold on, let me try again. I think this is the right path, though. What I could do as a workaround, and I'll show you in a second. Here, I can do this. Cosine theta minus 1 over cosine theta. Cosine of x minus 1 cosine of x. That's that function, and then I can see which one of these is the same. So let's try negative tangent sine first. Oh, oops. Hey, it's right on top. Boom, dunzos. Okay, so I think I did something wrong. I can try it again, but I know that was on the right track. Like cosine squared over cosine, minus 1 over cosine. Sine plus cosine equals 1. And then this becomes cosine squared minus 1 over cosine. And then if I subtract 1, cosine, and then I subtract sine of theta. Yeah, sine squared. So it's negative sine squared theta over cosine. Oh, I'm an idiot. Yeah, of course it's E. Yeah, this is just negative tangent theta times the extra sine. Yeah, it's E. So I was on the right path. Just messed up somewhere. Okay, 15 minutes for 13 problems. Not great. The graph in the figure above could be a portion of the graph of which of the following pairs of parametric equations? Oh, parametric. Oh, I totally don't remember how to do parametric. I'm going to guess and say it's got to be x equals the quadratic, the like exponent, I'm assuming, because that's how it goes left to right. I don't remember how this works, though. X equal. Oh, I think you can like substitute. There's something weird with this, where you can like substitute the y in for the t, and you get the original. I feel like I remember this. I haven't done this in a long time, so this is just not something I teach a lot. So I'm gonna roll with x equal, and it's going left. So I'm gonna roll with negative t squared minus 1, because then it's a shift to the left by 1. As if this were like, you know what I'm saying? As if this were x equals negative y squared minus 1. Because watch, that would be this. X equals negative y. Oops. You see what I'm saying? So I think that's the right answer. Just can't remember exactly how they'll do those. 39. The graphs of f and g are shown in the figure above. Which of the following is the graph of f minus g? Okay, so it would be, let's see. So here it's f minus g, which is this negative value. No, it has to be negative over here. Yeah, b looks good. C's out. D looks good. E's out. As long as it didn't say absolute value or anything, yeah. Now it's between B and D. It's going to be 0 at the middle, at the origin. That works for both. And then it goes negative over here. No, it's going to be positive over here. Oh, they both. Wait, what? Oh, shoot, it's so subtle. Okay, so then it's flattened out like for a while for 0. Let's see if that makes sense. And then, yeah, that does. That looks like it's about 0. See, because these are about equivalent. No, I'm sorry. This would be 1 minus a negative. This would be still big positive up here. And then down here, it should be, oh, I'm sorry, f minus negative. It should be bigger negative, and then get to 0, and then it's going big positive. So I don't like the flattening of this. It's definitely B. Yeah, that makes sense. If it was plus, it'd be the other one. Or, well, sort of. Okay, next, if sine of x over 4 is this, and x is between 0 and 4, cosine of theta is, okay. I think for this, I'm going to draw out a triangle. And theta's here, then opposite is x, the hypotenuse is 4. Then this is x squared. A squared plus x squared equals 16. A squared equals 16 minus x squared, and then take the square root. So this is square root of 16 minus x squared. So cosine of this angle is the adjacent over hypotenuse. So square root of 16 minus x squared over 4. Okay, good. Next. In the xy plane was the center of the circle. Okay, we got to complete the square. So it's x squared minus 10x. Half of that squared is 25. I have to do this fast. So I'm really running low on time. Squared plus 6y. Plus half of this is 3 is 9 equals 2. And then we have to add 9 and add 25 to the right side. And then this factors to x minus 5 squared plus y plus 3 squared equals, this doesn't matter because we don't want the radius, but it's 11 plus 25 is 36. So the center is at 5 comma negative 3. Which of the following equations has exactly 2 distinct real roots? 2 distinct real roots. Not this one. This would be 2, and nope, that's not real. Probably need a minus sign. It has exactly 2 distinct real roots. So this would be 1 and negative 1. I think it's this one. No, this would also be 1 and negative 1. 2 negative, this would be 2 negative 2, does it say exactly? This is 2 negative 2, 3 negative 3, so that's out. 2 distinct real roots. Oh, because this has double roots. So this has a multiplicity of, it would be like 1, yeah, it's not this one, it's this one, I think. It's 1 and negative 1. Okay. 43, no, not vectors. I need to review vectors as well. In the figure above, R and S are vectors of magnitude 4 and 8, respectively. The angle between the two vectors is 50. What is the magnitude of R plus S? So we add them like head to tail, like this. And we go, so here would be this. And then basically, I remember the magnitude is just this distance over here. Okay, and then this is 4. And then if this is 50, this is 50 up here. Oh, no, sorry. Sorry, this is supplementary. So this is 130 because this is 50 over here. And then do we have to use the law of cosines to get that? Hold on. Yeah, we have to use the law of cosines. So it's C equals a squared plus b squared minus, darn it, what's the law of cosines? 2ab cosine of c. Let's hope that's right. I could look it up, I guess, but let's just see if this is right. So this becomes, so we're trying to find c. So a squared, let's call a 8, so that's 64 plus b squared is 16 minus 2 times 8 times 4, which is 32. Times 32 cosine of 130. This is 64. This is 80 minus 64 cosine of 130. 64 times cosine of 130 equals negative 41. And then it's 80 minus that. I'll just say this minus 80 and then multiply by negative 1. So that's one. Oh, this should be c squared, sorry. And then we take the square root of that. Oops, take the square root of all of this to get c. It's about 11. Please, it's there. Yes. I think that was right. We'll go back. If the points 2b, 3, I feel like this is much harder than the first one. To the points 2b, 3, and b lie on the same plane, what is the value of b? They lie on the same line. Okay, sorry. So let's line it up. So the slope between all of them should be equivalent. Oh, sorry, b plus 3, negative 2. So I'll do that, and then I'll do a second setup to get slope. B plus 3, negative 2, and then b comma 7. And then let's subtract down, calculate slope. So 3 minus negative 2 over 2b minus plus 3 should equal negative 2 minus 7, subtract down, over b plus 3 minus b. Okay, these b's cancel out. This becomes positive. So this becomes 5 over 2b. That negative distributes and becomes negative and negative. So 2b minus b is b minus 3 equals negative 2 minus 7 is negative 9 over 3. We cross multiply. No, simplify. That becomes 3. That becomes 1. Then we cross multiply. 5 equals 3, negative 3 times b minus 3. Distribute, I guess. Negative 3b plus 9 equals 5. Subtract 9, subtract 9. 4 equals negative 3b. Divide by negative 3. And we get 4/3 positive. 5 minutes and 40 seconds. Okay, next. Which of the following functions is the same as its inverse function? Okay, the inverse of this. So the way we find the inverse is we switch that with x, switch this with y, and then isolate, multiply the y over here, divide by x, and yes, y equals 1 over x. It's the same. The inverse is the same. This one definitely not, and this one definitely not. But let's try it anyways. So this one would be x equals 1 over y plus 1. Subtract 1 over y. Multiply both sides by y, and then divide both sides by x minus 1. So that is not the same inverse. And it's going to be the same deal with this one, I think. But let's double check. Maybe I'm wrong. X equals 1 plus 1. Subtract 1, x minus 1 over y minus 1. Multiply both sides by y minus 1. Divide by x minus 1. And then y minus 1 equals 1 over x minus 1. Add 1. Oh, it is the same. So 1 and 3. Okay, see, I checked, made sure, good. The function above can be used to approximate the average monthly temperature in degrees Fahrenheit for Nome, Alaska. Integer values of T represent the first day of each month. 1, 2, 3, blah, blah, blah. Using calendar year month as the average temperature first reach 32. Plug in and chug. 32 equals. I could also graph this, but sine of 0.053t minus 2.57 plus 27.27. So subtract 27.27 and we get 32 minus 4.73 equals all of this. Well, let's just not even rewrite it. And then we have to divide this by 24.62 equals sine of 0.05 or 0.53, sorry, not 0.053, 0.53t minus 2.57. 4.73 divided by 24 divided by 24.62 equals 0.19212. Then I have to take the arc sine of this, so I'm going really fast, and then that frees that up, and then it's 0.53t minus 2.57. So inverse sine of that is sine of that answer is this. Is this did it say radians or degrees, by the way? I don't know. I'm assuming degrees. Okay, so then we've got 11.07 equals all this stuff. Then I have to isolate t, I have to add 2.57 and then divide by 0.53. Add 2.57 and divide by 0.53. 25. What? That can't be right. What did I do wrong there? Oh, that definitely can't be 4.73. That was wrong. 32 minus 24.62. Oh, God. 32 minus 24.6. I must have put the numbers in wrong. 7.38 divided by 24.62 equals that. And then take arc sine of that. Second answer equals that. And then 17 plus 2.57. No, this is even worse. What is up with my work? 27.72. Oh. Subtracted 27.72. I get it now. No, that was right. 4.73 divided by 24.62. Gotta be between 0 and 12. I mean, I don't know if it's. I'm gonna run out of time. Dang it, that sucks. So I came like almost five questions I missed, but I'll still take the time and do these. Hold on. So 32. All right, man. No, this is a hard one. 4.73. 4.73 divided by 20. Divided by 24.62. 0.19, and then arc sine of that. Maybe radians? Didn't say radians, but I guess let's do radians. Well, it's the same thing. And then, all right, let's stop the clock. And then you'd add 0.257. And then we divide by 0.53. And I get 5, so it's in May. I don't know why we'd need to use radians. That's my question, but I think that was the issue. I'm just not sure, but I'm pretty sure it's May. Okay, let's finish this off here. Okay, the terminal side of an angle theta in standard position. So by the way, that's a bummer I didn't finish it in the time. I think that I really wasted a lot of time on one of those questions, which I left blank still, so I'll go back and check it. But okay, the terminal side of an angle theta in standard position coincides with the line equation 5x plus y equals 0. Okay, as shown in the figure above, which of the following equals secant of theta? So it's y. This is really y equals negative 5x. Secant of theta. So we can make our triangle like this. Coming down here. And then secant of this angle here would be, secant is the inverse of cosine. So adjacent over hypotenuse, or really hypotenuse over adjacent. So let's just choose an arbitrary value here. Let's say x is 1. If x is 1, y is negative 5. Okay. So then, let's say x is negative 1, y is positive 5. All right. So then this would be a 1 value. This would be 5. And then this would be 1 squared plus 25, 20 squared root of 26. Okay, so secant, so again, cosine is adjacent over that. Secant is hypotenuse over adjacent, so it's square root of 26. And then cosine's negative in that quadrant, so it's negative square root of 26. A deposit of 1,000 is used to open an account that pays 8% annual interest compounded monthly. Okay, so here's the deposit. 1.08 to the t whatever. It's compounded monthly. Oh, my bad. A equals P times N plus R over N to the NTE, which is 12 NT. yeah, it's a song I made, so remember that. And then we've got how many months after the original? Well, the amount of the money first reached 2,000. So then we plug in 2,000 here, and we solve. Times all that. I'm not going to rewrite it. Divide by 1,000. I get 2 equals 0.08 divided by 12. 12 is, ooh. I don't like that number. Let's not do that yet. Equals 1 plus 8 over 12 to the 12t. Now we're going to take the log of both sides. Log of 2, log of this. And then this becomes, whatever this is, 12. And then that exponent comes down 12t times, let's actually do this, 1 plus 0.08. Oh, wait. Plus, oh, sorry. Second answer plus 1 equals that. And then we need to take the log of that. So that's 0.00288. And then this side is log of 2. So and then eventually we're going to divide log of 2 by that value. So let's just do it up here. Log of 2 divided by that. Answer equals 104.31 equals 12t. Divide by 12, divide by 12. $104 divided by 12. Oh wait, that is the number of months actually. This would give me the number of years, so it's 104.31. Ooh. Yeah, 105. Because 104.31 would be where it exactly happened, so 105 after. Blah, blah, blah. Okay, let a, b, x, w, x, y, z represent real numbers greater than 1. If a to the x equals b to the y, a to the w equals 1, which of the following statements must be true? Okay, let's see. Let's do a little substitution here. E to the x. Oh, watch this, watch this. If I take both these sides, hold on, to the w over x, okay? This becomes a to the w, and it means that a to the w equals b to the, and then these multiply wy over x, which means that b to the wy over x equals b to the z, which means that wy over x equals z, which means that wy equals xz. And I bet you that's there. I feel like that one I've seen before. That's a really hard one, but it's with a little substitution, you can knock that out. But that felt familiar. Okay, next, in the figure above, points B, C, B and C represent 2 different radar stations. Ship starts at point A, which is 6 kilometers from point B and sails in a straight line towards point C. When the ship is once again 6 kilometers, how far is it from point C? Got it. So they're saying when it's 6, what's this distance? trying to think, is this law of cosines or law of sines? Hold on. We can't use law of cosines because it's got to be the angle like wedged in here, and we don't have that. Hold on, let's see. We can do law of... Okay, these two angles are equal. I know that. Okay, so that's supplementary to both of them. Wait a minute. I know we got to use trig in here somehow. But how? Okay, if I did this, let's see if this works. If I draw an altitude straight down, and I create a right triangle here, and then I can get this whole distance, I can say... And then this angle up here would be 58. Not that that helps. And then 58, and then if I got that whole... Okay, let me at least try this. And then I got to go back to the other problem that I didn't finish. So if I want this distance, cosine of 32 equals adjacent, which is x over 10.6. So if I do 10.6 times cosine of 32, equals 8.989. So this whole thing is 8.989. Did it give any other distance? So I know that's 8. So it's got to be less than that. Okay. Check it out. It's got to be less than this because that's this distance. We got to remove that. So it's one of these two. Okay, I've at least figured it out that far. Then the question is, which one is it? So it's an isosceles triangle, 6 and 6. Does it give any other angles? I know there's some theorem that I can use for that. Oh, I can do... law of sines. So I can get this angle, which is... Okay, got it. So for this big triangle, I can do sine of, let's call this one x. Sine of x over 10.6 equals sine of 32 over 6, which is opposite, and then we cross multiply. So sine 10.6 times sine of 32. I think I already did that, right? Yeah, sine of 32 times 10.6. Equals 5.617. Equals sine of x. 6 divided by 6. So that divided by 6 is this. And then we take inverse sine of that. And we get 69.42. So that means this angle is 69.42. This angle is 69.42. This angle, therefore, is 111. Let's just say approximately. And then we can do law of... Hold on. Oh, and then 111, 32, 143. So then this little angle up here, if that's 143, that's 37. Now we can do law of sines. Okay, so then we do sine of 37 over x, which is this value, equals sine of 111. Oh, we can do sine of 32, actually. Sine of 32 over 6, right? Angle over opposite side, etc. So then we cross multiply. X sine of 32 equals 6 times sine of 37. 6 times 3.61 divided by sine of 32 divided by sine of 32. Still in degrees. And I get 6.8, whatever, it's that one. Because I approximate a little on the angles. Yowzers, that was so hard. I don't even know how far over I am on the time right now. Let's go back and do that last one, see if I can crack it, and then we will move on. Check the answers. This one. I know this is doable. I know this is so doable. I mean, I could just graph this. So like the two equations are this, and I'd say 1 equals k times 0.2 to the m. The other one is 16 equals k times 0.8 to the m. It's a system of equations. Oh, this is what I should have done. K equals 1 over 0.2 to the m, and then plug this in for k over here. So 16 equals 1 over 0.2 to the m times 0.8 to the m, which equals 16 equals 0.8 to the m over 0.2 to the m, and then we subtract. Oh, no. We can't because they're not the same base. Well, there's got to be a way to do this. It's 2 squared is 0.08. And then it's 0.8m. See, that's the problem if it's 0.8 versus 0.2, right? Like, if it was 2 and 8, that'd be easy. It'd be 2 cubed, and 8 would be 2 cubed, but it's not with the exponents, right? 0.2 to what power equals 0.8? And then, I guess, see, again, my thought is to take the log of this. Log of 16 equals, and then that becomes log of 0.8m minus log of 0.2m. That was what my initial thing was, but then it's like log of 16 equals, and then the m's come down, m log of 0.8 minus m log of 0.2. Then we can do this again where it's log of 16 equals m log of 0.8 over 0.2. So it's m log of 4. Log of 16 equals m times log of 4. And then log of 16 divided by log of 4. Wait, that's different than what I did last time. Log of divided by log of 4. 2. Okay, it worked that. I don't know what I did the first time. Okay, let me get my book and let's now check the answers. Let me see how I'm doing on time. Yeah, I'm like okay, so 17 minutes. So I think it went like 15 minutes over. Yeah, that's a bummer because I really do try and I usually, the last time I think I ran out of time by like a minute is when I think I tripped up on one of the problems and that just really messed me up. But this was also much harder. Hold on, let me get the book. All right, let's take a look. Okay. All right, I've got practice. Oh, there's more practices in here. I thought there was just 2. Oh, wow. I didn't even know that there were so many. There's 4 in here. Okay, we got CBBA. Next we have ABA. Wait, is that right? ABA, yeah. 7, now we're on to 8. EEBDE. EEBDE. 13 is ABDCD. 15 is wrong. It's D. Oh, no, it is D. What did I do? 13 is A, B, D, C, D. C, D. Okay, good. 18 is C, B, C, D, C. C, B, C, D. 23 is E, B, A, B, B. Yeah, that was right. Good. That one was a little iffy. 28 is B, E, C, A, E. B, E, C, A, E. 33 is A, A, D, B. Yeah, that was right. Good. A, A. Ooh. 35 is D. Darn it. What did I do? Hold on. Oh, I set that up right. Each time the paper is folded in half, the thickness is doubled. So okay, the paper can be folded in half. Oh, shoot. I forgot to convert to feet. It's 123 inches, which is 10 feet. No. Sad. Okay. Next is 36. B-E-E-B-A. Good. 41. B, C, D, E, C. B, C, D, E. Wait, 44 is E, right? Yeah. And then C. Yes, good. 46 is C, A, C, E, B. C, A, C, E, B. Oh, yeah. Okay, so look, I got one wrong, but to be honest, I'm going to answer all you guys' questions in a second. But to be honest, if I'm being real, I missed technically 7 because I ran out of time with 5 blank. So let's see what I would have gotten theoretically. Yeah, this one I was still gotten 800. This one you can get, I don't know if you can see this, but you can get 10 wrong on this one and still get an 800, which I could sense that this was a hard one. But anyways, there you have it. I hope those were helpful. Okay, it's C squared. Oh yeah, you caught it. A lot of stuff. Okay, I've never been here for a live stream. Hey Yuma, I hope you enjoyed it. AP Calc and BC videos. Yeah, one day. I barely teach Calc anymore, or tutor it for some reason, but I would love to get back into it and master it again. You're doing videos? Yes, I am starting Saturday. I'll be doing SAT videos for next Saturday. SAT, just get 5 wrong. Any tips? Practice. Honestly, I can't. That's the best I can tell you. Yeah, me too. Reading is hard. Don't choose copycat answers. Analyze every word in your choice, even if. Never mind. You just found it. It's C because you have -2 as well. Yeah. This is practice test 2 out of the official subject book. Please do more SAT QAS for the August. Yeah, I will be. Hey, can you do a reading? I don't know about the reading. Everybody keeps asking me, but I might get one of my verbal specialists to do one. Okay. What was your college major? My major was computer science and economics, so I double majored. And then after that, I went to law school. So I'm still a licensed attorney in California. I have no idea. I'm sure there's a faster way to do the last problem. I'm sure there is. Yeah, actually, no, there definitely is. I should have immediately tried to find that angle X here using the law of sines. I should have immediately tried to find that angle and then drawn this and then realized this angle is the same, then found this angle, then found this angle, and then use law of sines. So it's using law of sines twice, but that's the best you can do it. I didn't need to find this side. That was a waste of time. That helped me eliminate stuff, so that was cool, but that was it. Hey, man, thank you. I hope you appreciate this. I'm really happy, too, because I used Wirecast today, and it didn't crash. It was crashing a bunch of times before, and it was really frustrating. So that's really good news. Hopefully I can use it going forward because it's a better quality stream, and we'll have no more technical issues. Thank you guys so much for joining. Don't forget, the SAT Cram Week starts Saturday. We're going to be doing it straight Saturday through Friday, 7 days to get you guys ready. Thanks so much, and I wish you all the best of luck in your standardized tests, and I'll see you all. Yeah, please drop a like if you guys like this video, found it helpful. Please click like, subscribe if you want to see more. And that's it. I wish you all the best of luck, and I'll see you all next time. Take it easy.